Okay, I have a nice infinite series to evaluate today. We'll define a sequence recursively by the rules x1 is equal to a real number a, then x sub n plus 1 is x sub n plus x sub n squared for n greater than or equal to 1. And then we want to evaluate the sum as n goes from 1 to infinity of 1 over 1 plus x sub n. And I've got a reference graph over here of y equals x squared plus x, because it makes the analysis a little bit easier here. Okay, first note that a can't be negative 1, and if you start with an a that's between negative 1 and 0, then that a squared plus a will be between 0 and negative 1/4. Okay, so of course that makes a squared plus a between negative 1 and 1. Okay, so when you take that a squared plus a and plug it into x squared plus x to get x3, that will also be in negative 1 to 0. And that means that if we start with an a between negative 1 and 0, all the x sub n's will be between negative 1 and 0. They'll actually be between negative 1/4 and 0, which makes them between negative 1 and 0. But that makes all the values of 1 over 1 plus x sub n greater than or equal to 1. So by the divergence test, the series diverges because there's no way the limit of 1 plus 1 over x sub n can be equal to 0. Okay, so any a we start with has to be less than negative 1 or greater than 0. Okay, so let's start with an a that's less than negative 1 or greater than 0. And if we do that, the x sub n, starting with x2, will be all greater than 0. And of course that makes 1 over 1 plus x sub n greater than 0. And also you can see from the recursive formula that x sub n plus 1 is bigger than x sub n because it's equal to x sub n plus x sub n squared. Okay, so that means that x sub n plus 1 is bigger than x sub n. Okay, so in other words, the sequence of x sub n's is increasing. All right, let's look at our series here. We've got the sum as n goes from 1 to infinity, 1 over 1 plus x sub n, but that's equal to the sum as n goes from 1 to infinity of 1 over x sub n minus 1 over x sub n plus 1 over 1 plus x sub n. But this is equal to the sum as n goes from 1 to infinity of 1 over x sub n plus x sub n it'd be x sub n minus 1 minus x sub n. I'm just getting a common denominator here to combine these second two terms. Okay, so that x sub n minus 1 minus x sub n will be over our common denominator, x sub n times 1 plus x sub n. But that gives us the sum, as n goes from 1 to infinity, of 1 over x sub n put some parentheses in over here, 1 over x sub n minus 1 over, because these x sub n minus x sub n cancels here, Okay, so minus 1 over, and the denominator here is x sub n plus x sub n squared, but that's x sub n plus 1. Okay, so let's look at the nth partial sum for this series. Call it S sub n. Just start writing it out. X1 is a, so we get 1 over a. And then minus 1 over x2. Okay, and then plus 1 over x2 minus 1 over x3. Okay, and then plus, and so forth and so on, till we get to 1 over x sub n minus 1 minus 1 over x sub n. We've got one more term here. We get plus 1 over x sub n minus 1 over x sub n plus 1. And I think we can all see that this is telescoping. Those cancel. See, the negative 1 over x cubed would cancel with the next term if we wrote it. The 1 over x sub n minus 1 cancels with the term before it. And we can see these two canceling. Okay, so we get that s sub n is equal to 1 over a minus 1 over x sub n plus 1. Now, if you look at the sequence of s sub n's, since x sub n plus 1 is bigger than x sub n, that means 1 over x sub n plus 1 is smaller than 1 over x sub n. So that means that as n goes from, as our indices go from n to n plus 1 to n plus 2 and so forth, each time we increase the value of the index, we're subtracting less from 1 over a, so we get a bigger value of 1 over a minus 1 over x sub n plus 1. So s sub n is increasing, and it's obviously bounded above by 1 over a, but that means that the s sub n, the sequence of s sub n's, converges, but that's exactly what it means for the series to converge. Okay, so the series converges. And since the series converges, that means that the general term, the 1 over 1 plus x sub n, as we take its limit as n goes to infinity, that's going to be 0 by the divergence test. But that implies that the limit as n goes to infinity of x sub n is equal to infinity. Okay, so that means that the limit of x sub n plus 1 as n goes to infinity is infinity as well. So as n goes to infinity, the 1 over x sub n plus 1 goes to 0, and we get the limit of s sub n as n goes to infinity is equal to 1 over a Okay, I stopped the recording to fix a mistake. So here we are, we're taking the limit of s sub n as n goes to infinity, but since x sub n plus 1 goes to infinity, 1 over x sub n plus 1 goes to 0, and the limit of s sub n as n goes to infinity is equal to 1 over a, and that is the value of the series.